Thank you to Michaela for inviting me, and of course, thank you to TotalEnergies for allowing me to attend. And thank you for the challenge, by the way. I had a 7.5-hour train ride, and that allowed me to condense a bit what I have on LinkedIn. I used ChatGPT. No, I used Copilot. We're not allowed to use ChatGPT in TotalEnergies. So I used Copilot to help me generate slides. So you will judge if that was successful. Good. What I will discuss is just very briefly, I will run through actually the first two because I need time to discuss 3, 4, and 5. So I will first go through TotalEnergies, what it is. TotalEnergies EP Denmark. This is TotalEnergies. We used to be called Total. We changed to TotalEnergies a few years ago. And actually that is because we are a multi-energies company. We have 2 pillars. We have oil and gas and integrated power. We're 100 years now, this year. So we had a big celebration a few months ago. So just a little bit of information. It's Paris-based, global footprint, 130 countries. I think we have about 200 countries in the world, so pretty big footprint. 100,000 employees. So we changed, as I said, in 21 as a reflect of our strategy, and we are 25 on the Forbes Global 2000 list. Then about TotalEnergies EP Denmark. So I just traveled east, 7.5 hours by train. It used to be Maersk Oil. Maersk Oil was bought by TotalEnergies in 6 years ago. Production started 50 years ago, so we have platforms that are 50 years old, more than. We have about 1,200 people, and we actually provide almost all of the hydrocarbons that Denmark needs. I'm the head of the data office, and this is my mission: deliver fit-for-purpose data to fuel a data-driven decision-making culture. I'm an engineer by background, KU Leuven in Belgium, Flanders. I have a PhD in applied physics from Delft. I'm an engineer, geologist, and that means I know how to deal with fuzziness, because geology is a bit fuzzy. Engineering is very strict, so, or not so strict, but I know how to balance both. So Gen AI is something I find intriguing. Gen AI, short timeline. I think to know more about the present, you need to know the past. So to be prepared about the present and the future. So I'll dive into the past. First, 2025. It is when all started. Suddenly, ChatGPT was released in November 22. Suddenly, millions of people were using it. Everybody was very excited. A lot of companies were rushing because we need to use this. But was it the start? Actually, it wasn't. It actually started in 2012 with AlexNet. A breakthrough of performance in the yearly challenge of detecting if a picture is a cat or not a cat, is a dog or whatever. And there was a big set of data, ImageNet, with lots of data, and everybody could try. And you see here, it went from 26.2, that's the second, to 15.3. So that was a breakthrough. But people were not happy because it was very criticized. Because instead of using intelligent rule-based methods, it was suddenly using brute force. It was using NVIDIA GPUs, gaming graphic cards, to actually just crunch, and it came up with a good result. But actually, that is not the beginning either. It's actually 1950. And it's actually the Alan Turing. I don't know if you know Alan Turing. He's British. And he was actually the person who, with his Turing bomb, he cracked the Enigma, the German ciphering codes. And he actually, people claim that he shortened the war by several years. Then he was also the person who developed the Turing test. And the Turing test is to evaluate a machine's ability to exhibit intelligent behavior, indistinguishable from that of a human. So that's AI, that is, I mean. And then there was, in '58 at Cornell University in New York State, was Frank Rosenblatt. And they thought they could solve this easy, over summer actually. And actually, they finished something in 1960, but actually they didn't finish anything. It's now ChatGPT, OpenAI, and so on that is doing this. There's just one tragic note. I don't know if you know about Alan Turing's end. It's very tragic what happened to this brilliant person. So, in November 22, we had OpenAI release. 5 months later, this was on The Economist, a cover. Fear of missing out on ChatGPT. People were looking to adopt, very urgent. All different type of companies were rushing because, they could miss out. But then, another 5 months later, it was something else. Some companies were actually happy that they took it slow. And instead of fear of missing out, they were happy of the joy of missing out, to take it slowly. Because they started realizing that actually it was more complicated than that. That's my second part. There were actually lots of things you had to think about. It was not just rushing. You needed to understand what you were doing. Third part. So what happened? So what happened between November 22 and October 23? Less than a year, 11 months. This is actually a book that just was released. I've ordered it. I've only read the review, so be careful. But it's a new book by the historian and philosopher Harari. Yuval Noah Harari is from Israel, if I'm correct. And actually he calls, or Barack Obama, Mark Zuckerberg are fans of him. He's actually very critical to Silicon Valley, but they love him. So actually he's saying generative AI acts like a sophisticated statistical parrot. Another thing he says is there is misplaced trust. And I don't know if you remember, before ChatGPT was released in 22, there was a software engineer at Google who was actually working on something similar. And he was claiming that the program was thinking and had feelings. And he was fired because of that. So that's America. I don't know if it would be possible here, but okay. And this, an insight of his, and I don't claim it as being true, I just found it very interesting. He says AI and holy books act as infallible superhuman authority. And we need it. We want it. And that's why we want to believe Gen AI, that it is smart, it can help us. But does it? Hallucinations. We all talked your hallucination in the picture with the female and the male. Hallucinations are not a bug. They are a feature. They are essential. So actually, we need to be careful. It's our perspective. We call it an hallucination if it doesn't do what we think it has to do, and we call it. We are happy with it if it does what we want to do, but it's just chance, and not chance. You can steer it. You can steer much. Actually, I'm pretty good at steering it, but it's not the first go. It's never right. Always iterations. So these appointments reflect our expectations, not the AI in itself. It's ours. So just some examples. This is a well-known one. It's on the bug report system of OpenAI, and it is you're asking ChatGPT how many R's are in strawberry, and it consistently says 2. Are you sure? Yes, 2. Would you bet $1 million? Yes, 2. I mean. And that is, I'm not going into the technology, but it is how it is implemented. It is a feature of, it's a feature, it's not a bug. So it shouldn't be a bug report, but yeah. Another example is, it's actually inventing information. And that's actually what it's constructed for. So here is somebody I really admire, Cassie Kozyrkov. She was the chief decision scientist at Google. She resigned and she's now CEO of an AI startup. She's really, follow her, I mean it. And she has some really good videos and so on. She asks, when was John Milton born? He's known, so you can check this is correct. And then she asks, when is Joanna Milton born? So, doesn't know any Joanna Milton, so it makes something up. It says it's the eldest daughter and it's born in 54 and so on. It's just making something up. Another thing is the influence of training data, and that's actually dangerous. Everything is dangerous if you don't account for it, if you don't know what to do, especially in industrial applications. The influence of training data is enormous. That's what it's based on. So non-generally accepted beliefs, like, should I say it, QAnon, some president saying he won, or candidate president saying he won an election. It is actually, they found out that there is a bias, and that's because the internet has a bias. It is Western, educated, industrialized, rich, and democratic. That's that's the majority of the internet. So the biases may not be generalized globally. So there is a big risk with ethnic profiling, with women to men. It's in the data set. It didn't invent. So there is really a potential for perpetuating stereotypes and discrimination, just that you are aware of. But it has also very big strengths. So one of its strengths, it can deal with different contexts. It can deal with fakeness. It can deal well with that. It can deal with users writing comments to or reviews to a company, and you actually can decide if this is positive, negative, what it is about. It's very, very good at that. But somebody I know in Denmark, and he's the chief data scientist in a big technical company called Grundfos. He said he thinks that the scalability is a problem. It will not scale. He thinks that actually, because it is based on the internet, it is the average of the internet with the average intelligence of the internet. I don't want to say anything, but I do. but I think it is DeepMind, a Google subsidiary, has looked at ChatGPT, and it defines it as uneducated human intelligence. And they have 5 steps, and they go to supernatural human intelligence. But it's the first step. It's just the first step. You really need to guide it to get something that is useful. Yes. Okay, this is just an important reminder, and that's again Cassie. You should be very careful, because some people think generative AI is a solution for everything. It's not. There are lots of other things in the toolbox that actually may take more time, but you don't have the risk, and you don't have the complexity that you have with Gen AI. Yes, Gen AI you can generate in 20 minutes, 5 minutes, but it will not. You need to make sure that it's actually delivering what you want. And you really have to start with the business problem, not the technology. You really have to understand your use case well, and then decide if Gen AI is the solution. It might not. It might be something else. Actually, a good example of what can go wrong. This was February this year. It's actually interesting. Very interesting, I think. Air Canada has a chatbot. You can ask it questions as a user. And there was somebody with a death in the family, and there is a possibility to get cheap tickets. So she asked the bot, and it says, yes, just book, and then afterwards we'll settle it. And that's actually completely not the rule. And then it came to a court case. And Air Canada said, the chatbot is not ours, it is its own. You have to punish the chatbot, not us. And of course, the judge said, that's not gonna fly. They got a fine. So, but it is important. You are accountable. You are accountable for it as a company. You cannot hide behind OpenAI or Gen AI. It's not a legal entity. OpenAI is, but your chatbot isn't. Okay. Yes. Looking at the time. Trustworthy no, I will not trust. Now I will try to slow down. I have a bit of adrenaline. Trustworthy Gen AI for industrial applications. Do we think it can work? Here is some ideas of some people I know and that I think have an idea what might happen. Ariel Waller, I know him from 2006, I think. He's from the University of Oslo, and he thinks that combining AI with human reasoning can handle complex domain-specific tasks. He thinks that integrated structured knowledge and standards, so international standards, enhances AI capabilities. And actually what he didn't say it, but I mean, yes, he does. Focus on knowledge representation, ontology engineering, semantic integration, using semantic knowledge graphs. This is a picture from SINTEF. They have a CogniTwin project, and they define a cognitive twin as an advanced digital twin with cognitive capabilities that enable it to learn, adopt, and predict events automatically, autonomously. Autonomically, yes. Actually, it's not new, to be honest. Back in 2000, I was with TNO in Delft, and we were working for Shell. And actually, Shell had a big program called Smart Fields. And it was actually closed-loop reservoir management, actually using data from wells to predict actually your reservoir model. What we normally do is you have a geologist with a concept. Actually, a geologist always has 3 concepts. They say a geologist needs to have 3 different hands, because he always says on the one hand, on the other hand, and on the third hand. So a geologist has a model, has a theory. Then a geophysicist, that is me by training. We take measurements and we try to see how it looks like. And actually, our measurements are it's 2,000 meters underground. We have pulse sound waves that reflect. It is band limited, so it means we only can see a part, and we have to interpret a lot. So actually, what they did, instead of building a high resolution model that is actually sequential, first the geologist and the geophysicist with its best estimate, or perhaps 3 estimates, do a reservoir modeling, and then, so actually a lot of the uncertainty, a lot of the information is lost. You are condensing everything into 1 or 2 or 3 models. What Smart Fields was doing was actually putting it on its head and just saying, we just believe what the data says. We just use the data. And what they did is actually they estimated a very low resolution reservoir model, but it helped in managing the reservoir and get 5 to 10% more oil out of the ground. That's a lot of money. Oil and gas is, 5 to 10% more from the same reservoir. It's a lot of money. It's billions. So it's actually not a new concept. It's actually something that has been done before. And actually meteorological models are done by the same. It's called a method called Kalman filtering. It comes from there. Good. Then there is somebody else from the University of Western Australia, I think in Perth. I'm not sure I've ever met her, but I would like to. I heard you saying she's amazing. She's actually extending, we have natural language processing, but she calls technical language processing, by extending it, by integrating again knowledge, domain-specific knowledge, ontologies, and large language models. And actually what she's saying is semantic knowledge graphs again. Semantic knowledge graphs to structure, utilize technical data and extracting actionable information. So actually both call for knowledge graphs. And what is a knowledge graph? It's actually a representation of the complex set of relationships and domain-specific knowledge. So here you have a bit of a blurry picture, but a person, competency, loss of capability, competency level. So it's about a person, what he can, what he cannot do, and so on. And actually what you're doing is you actually use information and you say capability of an identifier, type competency, description, competency description, title, competency title. So I am a data manager and I am an advanced data manager. That's my title. in this way, you can build a lot of information in a very structured way, and you can reuse it in actually for machines to reason about it. It is possible to reason on top of this and to not create, but to infer new knowledge. Because it's in there implicitly, but you can infer it by using this. So the World Wide Web Consortium actually has quite a lot of standards that can do this. This is a nice transition to this Mr. Sir Tim Berners-Lee. Who knows who it is? And actually I saw on the program on Friday morning, one of his collaborators is doing a similar opening speech, and I'm so unhappy that I'm not here. But I will try to follow it online, and at least I will see it offline. Sir Tim Berners-Lee was the person who invented HTML, I think. Because the other one is doing the World Wide Web, I think. They're working together, at least. When he was at CERN, he did that way back. In 1999, he defined something called the semantic web, a vision. And he says, our current internet at that time is just linking text. Text pages. You have an URL and you can click on it and it goes to another page. But he says, yes, but we can do better. And he says, I have a vision of a semantic web. A semantic web where data is actually linked together. And actually, you define the data in such a way that you actually can give a set of data to somebody else in another company, in your own company, and actually the whole meaning of that data is still preserved. That you cannot do now. I mean, in another way you cannot do it. In a normal SQL database, you have a table. And actually the meaning of the things are implicit in this context. And what you actually do with semantic web is you make it explicit. You say, when I give an example, and it's actually an example from Jean-Charles, a colleague of mine. Orange. You think about a color. Or a fruit. Or a city in France. My wife is Dutch, so she thinks about her royal family, because that's the color of the royal family. So it's also a company, it's a telecom company in France. So if you say orange, it can mean at least 5 things. And by being explicit, I mean, I saw this and that. I mean, such and such, city in France, and so on. That is giving the context, and that's semantic web. And actually, it gives you interoperability, decentralization, because the data is spread. It doesn't need to be in one location. And it helps you in having the opportunity to have automated reasoning and smart agents. And actually, the impact, because I'm in the business, the impact is that it creates business value. It creates business value by having people to work to have the possibility to work with data that is normally in different silos. It is together, and that generates better decisions executed in reality, means value creation. Okay. So think of a semantic web as turning all the data into a big database, a virtual database, distributed database, but that is his vision. Good. Actually, I'm running early. I think you might get almost at your slot, because this is slide number 5. And actually, I think actually I could add some things because I'm at it. On Wednesday last week, there was a podcast by The Economist. I'm a subscriber of The Economist, and I enjoy it. They have a podcast called Babbage, and Babbage was, I think, the person they think came in 20th century. No, in the 18th century. 19th century, sorry, 1800s. He came up with the concept of a personal computer, of a computer. That's Babbage. So they use it for science and technology podcast. And they had a podcast on artificial general intelligence. How to make AI more like the human, And actually, they talk about knowledge graphs. They talk about actually adding physical rules. Like if you make a video of somebody throwing a ball to somebody else with generative AI, the ball is with me, and then the next split second it's with you. It doesn't understand inertia. It doesn't understand Newton. And actually those physical rules, some people think we can build it into the AI. So it can actually know how the physical world is working. It also talks about retrieval augmented generation, RAJ. And actually in TotalEnergies we already use that because we are rolling out, or not we, yeah. Our chief data officer in HQ is rolling out Copilot, Microsoft, and I'm not advocating pushing any brands, but we, as you saw, we have 100,000 employees. At the moment, 20,000 of them have access to Copilot. And Copilot has integrated retrieval augmented generation. And what it does, when you put in text, how you call it? A command? No. A prompt, yes. Thank you. When you put in a prompt, it analyzes the prompt and it looks like what are the key elements here. And then it actually does a search. It searches on the internet and it uses that as additional context in generating your response. And that's actually not what ChatGPT was doing, but now 3 days ago, so I should have updated, but oh no. Actually, I couldn't have updated it because this presentation was made in the train yesterday. Strawberry is the new generation of ChatGPT, and it actually is doing RAG. It is actually, after it has generated, it's actually checking, validating its result, and checking if what it is doing is actually right. So it would not hallucinate with, how was she called? The daughter of that other person from 1600. That would not do that. Actually, Cassie Kozyrkov, she compared both on a video on LinkedIn, and she compared both, and it now gives back, I don't know who this is, and please give me more information who you are talking about. So it actually is safer. I'm not saying it's safe, it is safer. And then, so I have a list. The last one is actually graph retrieval augmented generation. And that's actually retrieval augmented generation using semantic knowledge graphs, combining both. And actually, I think Google is very much working on that. So it's actually a circle back. Actually, what you're seeing, you had ImageNet competition. They were doing rule-based. And we are actually starting again with rule-based mixing with Gen AI. It's actually a full circle, as I see it. And Cassie calls it slow AI, because it takes much longer the computing power is also much higher. So it costs a lot of tokens or something as they call it. But it actually analyzes, retrieves, generates, fact checks, and so on. It is, yes. Good. I think I'm at my closure almost. I think I have 3 slides left. State of semantic knowledge graph adoption in industry and opportunity for collaboration. These are the companies I know are starting or are very advanced in using semantic knowledge graphs. There is, as you said last year, and I shouldn't point, my mother said, but last year, Katarina Kari, who was the lead or heading the ontology team in Zalando and then moved to IKEA and now is somewhere else, and she's also in your advisory board, I've understood, she actually made a very nice keynote speech. And she said they use semantic knowledge graph to make the search for a client, somebody who's on the website and trying to find something, much more relevant. And one thing she says, or there's 2 things actually. One thing she says is every time, especially in IKEA, I think, every time I need to do a use case, it's always a 7-digit number in euros. It's huge. And of course, IKEA has a big footprint, so that helps. But I know Airbus, I know TotalEnergies, we are doing it. Lego is just beginning. Michelin is it's very advanced. AWS, Microsoft, Google, they are the experts. When you Google, it's actually semantic knowledge graphs that help you and help you get the relevant stuff. So you were alluding to the European Commission and an event where I was in Brussels in October, November, where somebody from the Directorate General Research and Innovation, Peter Droll, he said there is a huge untapped potential as 80% of the industrial data is never used. And he actually said, as a mission, as an expectation, can you do something about this with semantic knowledge graphs? And of course, we cannot solve the whole thing, but I think we can do something if we work together. So, and I think it is pre-competitive. It's actually at the level that we're not going into each other's intellectual property. I've also thought about what can semantic knowledge graphs do for Industry 4? And I think, just from what I have to deal with as data, I think there are lots of things where I think we can build a semantic knowledge graph. And then I think there are synergy effects. If you have 2, 3, 4, 5, all of these domains together, it's 1 + 1 is much more than 2. It will give enhanced decision making. It will open up silos that we have from before, that you can mix and match data that is relevant in decision making. It will improve efficiency, compliance and transparency. And it will help actually in using or getting something at least more trustworthy than what we have now. I don't know if we will be able to solve everything, but I think it will make generative AI more relevant for industry. And then and there was another thing I was going to say about Kari. just a side note she made. She said that it's more and more difficult to get people with knowledge about knowledge graphs. And they're getting more expensive. And then I came across this. Just very recently, Samsung bought Oxford Semantic Technologies. I know one of the founders. He was in. I know him from 2008, I think. And we actually were working together on writing an Optique EU proposal together, where I would be responsible for a use case with Equinor on subsurface, and there was another use case with Siemens on troubleshooting for big turbines, so power generating turbines. And Ian Horrocks, a professor at Oxford University, he was the scientific director. And it was a big success. 2012, it was approved. And at that time, for reasons outside of my control, I couldn't take my position in the project. So I left the company I was, and I started working for another company. But I think this indicates that Samsung is seeing what semantic knowledge graphs can do. And I don't think they're the only one. As I said, Microsoft, Google, and Amazon Web Services are doing the same. I wouldn't be surprised if Apple is doing it. I don't know about it, but I would be surprised. So that's my conclusion. I think semantic knowledge graphs are becoming more and more relevant. And that's actually my my final. I've understood it might be difficult to do questions, but did I succeed?
I think we can have a really big round of applause for Frédéric's overview, because this was phenomenal.